Hello, everyone. My name is Badr Abdullah, and it's my pleasure today to present our work on the nature of discrete speech representations in multilingual self-supervised models. This is a joint work with Maqsood, Shaik, and Dietrich Klakow from the Department of Language Science and Technology at Saarland University. Self-supervision has emerged as an effective paradigm for learning representations of spoken language from raw, untranscribed audio. And one advantage of these self-supervised speech models that they can be pre-trained on a large sample of languages, which actually facilitates cross-linguistic transfer for low resource languages. And recent self-supervised speech models actually include a shared quantization module within the model's architecture, and this actually this quantization module transforms the continuous acoustic input into a sequence of discrete units. And one of these multilingual models is the XLSR model, which was pre-trained on 53 languages. And this is figure 1 from the respective paper, and here as it's being shown, so the quantization module maps the frame representations into discrete units, and the authors of this paper hypothesize that the discrete unit inventories are going to be similar, are going to be different across the languages, with some overlap that correlates with the language similarity. So we actually wanted to test this hypothesis whether these discrete units are actually language specific or whether they're actually shared across the languages. So we looked at the inventories of these discrete units. On the XLSR paper, the authors expected that these discrete units will look like this. So there will be some overlap between the languages based on the language similarity, but in most cases, each language would have its own discrete unit inventory. But to our surprise, we actually found that the discrete unit inventories are actually identical across different languages. So we had to revise our research question to can we still predict the language of the speaker or a speech sample from the discrete representation of the utterance. So even if the discrete unit inventory across the languages are identical, we could still predict the language ID if the languages exhibit different distributions over these discrete units. So to answer our research question, we use the spoken language identification as a probing task. We use the common voice speech corpus, or a subsample of this corpus that consists of 16 Indo-European languages from different subgroups within Indo-European. And our language sample, even though it comes from the same language family, but it exhibits a reasonable phonetic and phonological diversity. So this is our experimental results. So as a baseline, we use the majority class, and as a top line, we actually fine-tune the models to predict the language ID of the speech sample, and we compare between the multilingual XLSR model with a monolingual English model. So this is the results of the probing task for the language ID, for the spoken language ID, and the measure is accuracy. The higher, the better. So we trained 2 symbol linear classifiers based on the discrete units, where we consider every speech sample as a bag of words or a bag of discrete units, and we observed that we only observe a very small improvement compared to the baseline, which shows that the distributions across the different languages are quite similar. So so every language would exhibit a similar distribution over these discrete units compared to the other language, which means we actually cannot really we actually cannot predict the language ID easily from this bag of words representation or from this bag of discrete units representations. But when we trained a sequential LSTM model on the sequence of discrete units, here we observe a significant gain over the baseline. And surprisingly, the monolingual English model actually can predict the language ID better than the multilingual model. And this has to do with the fact that this model has discrete units that are less abstract. Therefore, it's better at approximating the phonotactics of the languages. We also trained several classifiers based on the continuous representation. So here we don't use the discrete units, and we find that we can actually get much higher accuracy for the language ID. And this also shows that it's not really trivial to predict the language ID from the discrete representation. So taken together, this indicates that the latent discrete speech representations in self-supervised speech models actually correspond to language universal subphonetic events. So they are speech sounds, they correspond to speech sounds that exist in all the languages, but they don't actually correspond to higher language, let's say they don't correspond to higher level of abstractions, so they don't correspond to language-specific abstract phoneme inventories. So thank you very much for your attention, and we look forward to your questions.